Hi folks, I'm just gonna make a short video about a particular topic in Nginx, the web server. The topic is rate limiting. It says about how Nginx rate limiting works. It has an analogy that says it's a leaking bucket of water. Okay, this bucket has holes on it, and I guess the waters going into the bucket are the requests, and the leaky parts, it means the requests are processed, and the ones that are overflowing, they are like a rejected requests. Okay, so that's the analogy over here. Yeah, so here what it's doing is you're first defining a key that will associate itself with a shared memory zone. So this binary remote address is the remote address in binary form, and we use that as a key. And this zone parameter means the name of the shared memory zone. This time it's called my limit, which is 10 megabyte in size. Okay, and here is it's the rate limiting 10 requests per second. Okay, so this is the hard-coded rate, and here this is just specifying which shared memory zone to use for this location, the login page. Okay, and we're using my limit that's defined up here, and this is just proxy pass to an upstream server. Okay, so basically this is the barebone rate limiting configuration. Okay, the key point to realize is, in this case, if too many requests come at once, it will process the first one and discard everything else. Okay, discard the rest. Let me just yeah, so this is hard-coded. The rate is hard-coded over here, 10 requests per second. Okay, that's equivalent to one request every 100 milliseconds. Okay, so that's useful because you can illustrate the following. Okay, so if a request is arrived, and at the second if first one is processed and another comes before 100 milliseconds, then that second request is discarded, it's rejected. Okay, alright, so that's not what we want. So we need something called this burst parameter. Okay, yeah, so it says here, what if we get two requests within 100 milliseconds of each other? The second request For the second request, Nginx returns status code 503, so it's an error. Okay, that's not what we want. So if we use the burst parameter, burst of 20 means it's like a buffer. Okay, so or the size of a queue. Okay, what it means is under this current configuration, it means if simultaneous requests are made, they are not rejected but placed into the queue of size 20 requests. Okay, and if this burst queue is full, then the next requests are rejected. Okay, so there is a limit to how many requests you can forward to the queue. Okay, so think of burst parameter as a size of a queue. Okay, so I'll say it again. So if 19 requests are currently residing in the queue, and 2 requests comes in simultaneously, the first one will be accepted into the queue. Okay, after a delay of, in our case, 100 milliseconds, but the second one will be rejected. Okay, because now the queue is full. It has 20 requests already. Okay, so any subsequent request will be rejected provided the queue is full. Okay, so we come to a no delay parameter. So the difference between this one and this one is the no delay parameter. I just told you that for our example, the delay in which the Nginx process, sorry, the delay in which the request is forwarded to the queue is 100 milliseconds. Okay, so in this version, every time you want to forward a request into the queue, there's a delay of 100 milliseconds. But if you assign a no delay parameter, it will add those requests to the burst queue without delay, provided the queue is not full. Okay, so that's the difference. Now it's a two-stage rate limiting. The difference is, as well as assigning a burst parameter, you also assign a delay parameter. Okay, what it does is the delay of 8 means 8 subsequent requests will be added to or forwarded to the burst queue without delay, 8 of them, but the next 4 requests will be added to the queue only after the delay. Okay, so each iteration is 100 milliseconds. Okay, so you have to wait at least 100 milliseconds, and like before, any request when the queue is full will be rejected. Okay, so here the picture will tell you what's going on. Here the hard-coded rate limit is 5 requests per second. The burst queue is 12 and delay is 8. Okay, so these are first 3 seconds what's going on. Okay, so the first 8 requests, 1 2 3 4 5 6 7 8 here, they're immediately forwarded to the queue. Okay, because of delay equaling 8. But the next 4, when they come, these 4, they will be delayed. Okay, and after that the bus queue is already full, right? Because 8 plus 4 is 4. So any in here there's 3 more requests after that, they're rejected. These red, they're rejected. And because it clears 5 requests per second, we have 5 more rooms to forward it to the queue. So these next 4, they're accepted, but they're delayed before being forwarded to the queue. Okay, and then the queue is full again, so the next one is rejected. Alright, I hope that makes it easier. Yeah, so one point to remember is after the bus queue is full, even if there is a room in the queue, the subsequent request will be delayed. Okay, only the first 8 requests are forwarded without delay. And what I mean by delay is in this example, I guess it will be 1 request per 1 request per 50 milliseconds maybe. So that's the delay. Okay, so it means it would take at least 50 milliseconds for a request residing in the queue will be processed and removed from the queue, because they're already processed. Okay, so that's what delay means. Okay, just finishing off, don't confuse what I said with the delay parameter. They are 2 different things. In this case, it's the maximum size that in this case the first 8 requests will be forwarded to the queue without delay. Okay, all the subsequent requests, they will be delayed and accepted given that the burst queue is not full. So any subsequent request will be delayed, in this case by 50 milliseconds, given the queue is not full. Okay, here's some advanced examples. Do we want to go through them? Well, yeah, I guess I'll just go through this one for fun. So I'm guessing that this means you're trying to set the value of the variable limit. Okay, so by default the limit is 1. These 2 blocks, they are 0. Okay, and if limit is 0, then limit key is empty string. If limit is 1, then it's set to limit key is set to the binary remote address. So it's only 1 if they're not in the allowed white list. Okay, sorry, it's only 1 if it's only 0 if they're in the allow list. Okay, otherwise it's all 1. So here it's you're assigning a shared memory zone. So for the root location, okay, so this is the key. If the limit is 1, then limit key will be binary remote address. Okay, so this rate limiting or 5 requests per second, it will only take effect if the limit key is populated by binary remote address, and that's only if they're not in the allowed list. Okay, that's only if the limit is set to default. Okay, so this is a way of limiting the rate based on a allow list. Okay, thank you.